All right, so today we're going to be talking about factoring polynomials, which is basically taking something that's kind of long and drawn out, like those multiplication problems we did today, and working them backwards. We're going to be working them into factors. So a few things to remember, you'll see what I mean when we get there. You should already know all of these things at the top. Solutions are the opposite of factors, so like if you have x plus 3, that gives you an answer of x equals negative 3. Degree equals the number of solutions. If you have x to the third, that means you should be expecting 3 answers. You should always factor out the GCF first. We're going to do an example like that. And then just remember your basic trinomial, bottoms up, and difference of squares factoring. Today we're going to add to that, and I'm going to move quickly. We're going to add to that sum and difference of cubes, which is a new pattern. It's similar to difference of squares, but there's a few differences there. And then, well, that's not a word, but it should say grouping as a factoring method, and we'll look at that example today too. So let's go ahead and get started. So this first example is actually just a review of the factoring that we've done so far. It's just multi-step factoring. So notice in this example, I want to start by taking out the GCF. That should always be our first step. So I'm going to take out 6x here. Oh, that's a lie. I'm going to take out 3x, which is going to leave me with 2x squared plus 5x plus 2. Now remember, this GCF will come down in the front here. And now I need to consider what is left inside. And so this left inside should make me think x game. I'm working my trinomial here. So I'm going to do two numbers that multiply to give me 4 and add to give me 5. And those are 4 and 1. And remember, because I multiplied by that 4, I'm going to need to divide, by that 2, I'm going to need to divide by 2. So I'm going to set up my two factors, x plus 4 over 2 and x plus 1 over 2. This GCF is just going to track down in the front. It's not doing anything. And then we want to simplify and get everything back where it belongs. So 4 does divide by 2, so this factor here is going to be x plus 2. And then when the 2 doesn't divide, remember it comes to the front, 2x plus 1. Now something I want you to check and be in the habit of checking, especially now that we're moving on to more complicated factoring, is that things get back where they belong. So one thing that you can do, if we multiply, let me actually underline. So if I multiply these x parts together, 3x times x times 2x should give me 6x to the third. So the firsts all got back where they belong. And then I can check the lasts. This 3 is actually still distributing, so 3x times 2 times 1 does indeed give me this 6x back here, so that all checks out. All right, the second thing we want to talk about is some of these new factoring patterns. So you already know difference of squares. You may not have seen it written that way, but you understand that we break like the perfect square apart into its two components and they create conjugates. So what's new today that we need to be taking a note of is sum and difference of cubes. And I'm going to do an example to kind of explain how that works. But that is these two right here, and I would write those down for yourself. Just write the pattern, sum and difference of cubes. All right, so our cube numbers they're perfect cube numbers. That's where you have like 2 times 2 times 2, what does that equal? So let me make a little list of those for you. All right, there's your little list at the top that I would add to your notes for reference. I'll have that on the board for you tomorrow too, just so we can keep practicing with those. So let's look at how we actually factor one of these problems. We're going to factor this using different. And what I've found is the most helpful is to write this out. So I'm going to write out 27x to the third is a cube number because it is 3x times 3x times 3x. Similarly, 64 is a cube number because it is 4 times 4 times 4. So when we do this difference of cubes or sum of cubes pattern, there's always a short factor and a long factor. Now the short factor is exactly what you would think. It is 3x plus 4. It's just one of each of those. The long factor makes sense for a minute, okay? So I should have written an x there. I've got 3x times 3x left, which is going to make this first blank here 9x squared. And then I have 4 times 4 left, which is going to make the last part 16. And you'll notice from the patterns you wrote above, this is what I have. The strange part is this part here in the middle. And the rule is you take one of each, multiply, and flip them. So for instance, 3x times 4 is 12x, but I need to flip the sign, so this should be minus 12x. Okay, so here's one for you to try on your own. So I want you to break that up, push pause on the video, and see if you can get to this final answer. And if you don't get here, then you'll know what you need to ask about tomorrow. So there's the final answer for that question. Okay, so this is our last factoring type on grouping. So a few things that I want you to know. First of all, grouping generally happens when you have 4 terms. It can happen with 6 or even more, but 4 is the most common. And when we do grouping, we're going to be looking for GCF, right? We're talking about common factors. So in this example, when we group, we're going to pair things together or put them into groups. And remember, again, we're going to use GCF. So I notice this first group, my GCF is x squared. It's going to leave me with x plus 1. And GCF comes down to the front. And on my second group, I notice the GCF is negative 4, which again is going to leave me with x plus 1. This comes down to the front. And what you should notice, one of the most important things to notice here is that these 2 factors should match. Because the reason is that now we're going to take the GCF out of this entire set, and the GCF is x plus 1 because they match. So if you take x plus 1 out, you are left with x squared minus 4, and then this GCF of x plus 1 comes to the front. Generally, that would be the end, but you should always check to see if anything keeps going. And in this circumstance, this right here is difference of squares. So we're going to split it apart again. It's going to become x plus 2, x minus 2, and then that x plus 1 factor falls down. All right, so just like with the last one, I'm going to give you one to try on your own. All right, so looking at this example, I would copy that and see what you can get. And the final answer that I got here, or that you should get, is 3x plus 2, x squared plus 1. Notice in this case that this does not go any further because it's addition. So this is stuck because of the plus sign.